in photogrammetry and in general in computer vision, the algorithm used the process called image matching or dense image matching for processing of several hundred high resolution UAS-based images, and therefore to provide finally automatic 3D reconstruction of the man-made or natural object. The general step for 3D reconstruction is extraction of corresponding feature, like basic photogrammetry. You want the conjugate point between the two images, or even more in this case, so maybe more than 20, 30 images in overlapping images, and then computing the 3D information. We try to reconstruct the depth information using the corresponding pixel in 2D image. This we call it the 3D reconstruction. And this is the basic idea behind the computer vision. And then you have the 3D product, the point cloud as the basic and the main product, and using the point cloud we go to generate the DSM, correct the images by DSM, and to generate orthophoto, mesh model, texture model, and so on. So there are many 3D reconstruction tools have been recently provided, especially using the UAV data. There are many commercial and open source tools and a software to handle all the steps of an image-based 3D modeling. But the most important issue is select the best solution for high quality and high density point cloud generation in order to 3D modeling and also the mapping of the area. There are several work has been already done in this regard. I mean, comparing several software. Oh, this is Turkish. How to? Okay, this is late. There are several work has been already done. You see that there are all recent. I mean, starting from 2013 from Norbert Haller, and 2017 they have already evaluated several software, which are especially for the UAV data, and different case studies, house forested area underwater, forest farm, and in this case we are going to evaluate those software over the historical site. The software that has been selected, they are, they're mentioned by, I think, Mr. Pollack, but they are not free. They are some trial version, but they are mainly commercial. So we try to select those software which we could obtain the license for short-term working, officially, and then try to evaluate them. They are mainly picked for the photo scan, surf, and 3D survey. So therefore, the objective is to evaluate the commonly used UAS-based photogrammetry software in order to generate high-quality point cloud. The case study is, as I said, this is the Harire area. Dr. Alizadeh Ashraki already yesterday showed some product of his processing for this area. And this is the Harire area, this is an ancient city, and this is one of the products at the end. The elevation variation is between 0 to 14 meters in this area, and these are the software that we have been chosen for the evaluation. This is the basic step that we have. We have image acquisition using the UAV data, integrating GPS IMU information, and together with the stereo image that has been captured during the mission. And we try to evaluate those software, and we use them to generate the dense point cloud and then DSM, and try to compare the quality of the dense point cloud and also DSM. The comparison is in two area. One area is the point cloud in vector area, and another one is the raster area, which is interpolated point cloud to generate the DSM. An accuracy evaluation is a two-part geometric or quantitative evaluation, and visual or qualitative evaluation. This is the system that had been used, DJI Phantom 4 Pro. This is the 300 aerial image. Only 89 images had been selected, which are belong to the site, and you see that this is something like 1 centimeter spatial resolution, 40 meter flying altitude. So the software that had been used, the common workflow, the pose estimation, this is similar in all the tools: image alignment, type point generation, dense point cloud generation. They are all based on the new approach for image stereo matching, which is called semi-global matching, which is invented, which is reported by Dr. Hirschmuller from German Aerospace Center. It's called SGM. The base is SGM algorithm for stereo matching, but they did some customization in each software. I mean, the algorithm is SGM, and then after generating the dense point, individual dense point cloud, they did some topology processing to generate the model. The final output is the dense point cloud, and then DSM generated. So with another software, the software produced with their own algorithm, which sometimes is not clear. But we did not use the DSM, which is produced by their own software. We just took the point cloud data and put all individual point cloud in another software, according to the same parameter and the same algorithm, which is inverse distance weighting algorithm, to generate DSM in 2 centimeter. So the accuracy assessment is, as I said, is some quantitative and qualitative. For quantitative, we use some statistical analysis, some standard measures, mean of error, root mean square, standard deviation, and some robust measurement, median of error, normalized median, absolute deviation, and sample quantile of error. And on the other hand, you also have some visual interpretation, which we call it qualitative. And this is the point cloud quality, height profile, and QQ plot that we will show it later on. So the results, so we start to show the result. This is the first table showing the result. I just go to some specific results, since so I should care about the time or so, because this is before lunch. We should close it on time. According to the number of key points extracted per image, a Pix4D mapper extracted higher key point for each, in average, for each images. Ashore had not reported anything regarding to this option. Regarding to the number of, conjugated dense points, so a 3D survey produced less data. You see that 1 million, and the other are 20-something million, 24 million, 23 million, Pix4D, and Shore 13 million points. And yeah, this is Agisoft is 24 million. Regarding to the point spacing, you see that the Agisoft photo scan and Pix4D Pro generate similarly, the best quality, and this is 0.016 meter. The spacing, average spacing between the points. Regarding to the spatial error of point cloud, 3D survey and Agisoft more or less similar and better than the other. And regarding to the processing time, the Pix4D it's less comparing to the others. That took 5 hours. Using the computer with the Core i5, 16 gigabyte RAM, and processing on GPU and graphic card. This is probably the most important one. It has direct effect on the speed of processing. Let's go to some qualitative assessment. This is the output that we have got from the 3D survey software. You see that the points are somehow sparse comparing to the other that you will see later on. That you see that so many white point here, that this is not filled. I mean, even in this zoom, if you zoom it in more, you will see more points. So we have some poor reconstruction in trees. You know, trees reconstruction always are on a challenge, and because of the irregular behavior, irregular shape of the tree, and also some movement of the object. You know, even if the leaves are very light, with a very small wind, it can move it. Therefore, finding the conjugated point, finding the corresponding point, it is too high. It's too difficult. Sorry. Shadow. So shadow is coming from, I mean, since we have less images, I mean, corresponding to this area, just extracting, I mean, and also the quality of image in the shadow area, it's less. Therefore, finding the point, the 3D point, is a bit more difficult. The low density that we see, again, trees, some smoothing effect on the hilly area. If we see the other images, for example, here, that we got from Aggie's photo scan, this smoothing effect is not that much visible. That means we have less point, therefore the algorithm has been smoothen the area a bit. Again, we have some the poor on trees, the pre-construction